We're now going to go ahead and take a look at a different type of sequence. We've looked at an arithmetic sequence, and that's where you added the same number each time to go from one term to the next term. We're now going to look at a sequence called a geometric sequence. And a geometric sequence is basically when you are multiplying by the same number to go from one term to the next term each and every time. We really are dealing with what's referred to as a common ratio, and that's what you're multiplying by each time. We are referring to the common ratio as r. So here's an example of a geometric sequence. We're multiplying by 3 each time, so r would be 3. Our 5 times 3 is 15. Our 15 times 3 is 45. Our 45 times 3 is a 135. So r is our common ratio. We're multiplying by that by each time of 3, so it's a geometric sequence. And once again, it's a sequence because we're only listing these, separating them with commas. If we had plus signs in there, it'd be a geometric series. Here's your formula for the geometric sequence. You're going to want to know this one, just like we had a couple formulas earlier. Your a sub 1 is still your first term. N, in this case it happens to be an exponent, is still your position. But we didn't have an r before, we had a d before, because you're adding the same thing each time. We now have an r. R is referred to once again as your common ratio. You can always find your common ratio by taking one term divided by the previous term. So here we need to find the next 3 terms, and we need to find the 10th term. To find r, you can take any term you want, say the second term. Therefore, I'll have to divide it by the first term. And in this case, I would have it simplified down to 1/3. You could also get that, and should double check it to make sure it happens with the other terms. So I'll take my third term of a 12, divided by my second term, the term right before it, and yes, I once again get that 1/3. So here we are multiplying by 1/3 each and every time. So to get the next term, I'll take 12 times 1/3, and I get 4. 4 times 1/3, and I get 4/3. 4/3 times 1/3, and I get my 4/9. Now I can continue to list these till I get to my 10th term, or I could use my formula. I like to use my formula here because if I had to get to my 100th term, that means I'd have to list a lot of numbers. So the formula allows you to get to any term you want, no matter how far down the line it is. Here's my formula. I got to plug in my first term, which is at 108. Got to plug in my r, which I figured out, which is at 1/3. And then I got to go ahead and have my n minus 1. That's my general formula. Well, when I want my 10th term, that's my position. And remember, n is always your position. So you're going to go 108, 1/3, plug in 10. Then to work this out, remember, you need to do your exponent first. So you get a 9 as an exponent. Then go ahead and type that into your calculator. And then you end up getting 4 over 729. And we need to do the same type of thing over here. We need to first of all figure out your ratio. So you could take your 6 divided by your 3 and you get 2. Or your 12 and divide by 6 and you get 2. So we're multiplying by 2 each time. That's your common ratio. So you got to multiply by your 12 by 2 again to get to the next one, and so that's 24. Take that and multiply it by 2 to get the next one, and you get 48. Take 48 times 2 to get 96. Then we're going to go ahead and find the 10th term. Well, to find the 10th term, we're going to use our formula. We'll take our first term, which is 3, our r, which we figured out, which was 2, and then we'll go with an n minus 1. That's our general formula to actually figure out what n is. And that n right there is in the wrong location. That n should be down here as a subscript. Sorry about that. So we'll plug in our n being 10. and 10 minus 1 is 9. So we get 2 to the ninth times 3. You can use your calculator. You get 1,536. So we need to find the seventh term of our geometric sequence. We know our third term, and we know our ratio. Couple ways to do this one. You could say, well, if I know my third term is 96, to get to my fourth term, I know I just have to multiply by 2. And then I just get 192. So then I know to get my fifth term, I got to take that 192, the fourth one, times it by 2, and I get this. And just keep multiplying by 2 until you get there. That's one way to do it. Another way you could do it is say, well, I'm going to treat this as like my first term. And then since that's 2 smaller than this, my seventh term would really be like looking for my fifth term. And so then you could go your first term times your ratio of 2 raised to the n, which is your term you're looking for, of 5, minus 1, which is a 96, times 2 to the fourth. And that ends up giving you the same number right here. Doesn't make a difference whichever way you choose to do it. Well, we had arithmetic means before, and those were numbers that basically formed an arithmetic series, a sequence in between any two given numbers. Same type of thing here with geometric, except it forms a geometric sequence. So the missing terms between two non-consecutive terms of a geometric sequence is called geometric means. So here we need to find the three geometric means between these two numbers. So I'm going to treat the first one here as my first term. Then, since we're trying to find three numbers in between, I got to leave 3 spaces. And then I got to go ahead and put in my last number here. So my 3.12 is in the first position. This is my second number, my third number, my fourth number, and this is then my fifth number. So I can use my formula of an a sub n equaling my first term times r to the n minus 1 to help me out here. I know my first term. Now I'm going to go ahead and plug my last term in, and I'm going to plug in the position of that last term. This will then allow me to be able to figure out what r is. So my last position, or last term, my first term, r to the position of the last term, minus 1. The n here always has to match up with the position of this one here. So I really get all this to the fourth power. To solve this, I got to get rid of the 3.12, so I'll go ahead and divide. I get 16 equals r to the fourth. Take your fourth root, and you really get a plus 2, or you can also have a minus 2. So then let's go ahead and list these out. We're going to actually have 2 different sets. One where r is a positive 2. So remember to go from here to here, you're going to multiply by r, so you're going to multiply by 2. Then to get to the next term, you got to take this times 2. To get to the next term, you got to take this times 2. And by the way, if we take this 24.96 and multiply it by 2, you should get your 49.92, and we end up doing that. But we have a second r, so we've got to consider a second set of answers. You could have r being negative 2. So you could take your 3.12, multiply it by negative 2. Take your second term now, multiply it by negative 2. Multiply that by negative 2, and we get this. And if we multiply this by negative 2, yes, we do get our last term.